When you evaluate a logarithm, the answer to your logarithm is going to be an exponent. So basically, if I had something like I have here with log 4 of 16, we need to be thinking, 4 to what power is 16? So the answer is 4 squared is 16. So that means the answer to my logarithm, or this whole thing, log base 4 of 16, will evaluate to 2. Now, to get good at this, first we're going to practice just evaluating some exponents. I'll work a few of these with you, and then you might want to pause your video and see what you can do on your own. For this first one, you're just saying 2 to what power is 4? So your answer would be 2. For one like this, you have 2 to what power is 1/2? Well, to move it from the top to the bottom, that would be a -1. And then on this last one, 5 to what power is 1? Remember, anything to the 0 power is 1. A lot of exponent rules come into play as we're trying this. Go ahead and pause your video, try some of the rest of these, and then we'll go through them quickly. Okay, on this next one, you could have a 3, and then this one would be 4 and 5. On the next row, that should have been a -2 because 2 squared is 4. So to get it to go on the bottom, it's a -2. On the next one, that's just a -1, a -2. And then these last couple are a little tricky. You might say, well, I know that 2 squared is 4. Well, if 2 squared is 4, to go backwards, it's 4 to the 1/2 is 2. And remember, 4 to the 1/2 is the same thing as square root of 4. So that means square root of 4 really is equal to 2. So your answer there for your exponent is 1/2. So basically for the next one, I would think 4 to the third is 64. So 64 to the 1/3, aka the cube root of 64, is equal to 4. And on this last one, it looks weird, but notice that if they're equal and the bases are the same, then clearly x has to be 3, because if the bases are the same, it's basically like you can cancel them out, pretend like they're not there, and you can just get an x equals 3. Okay, now we're going to use what we just did to evaluate some logs. So on this next one, I say 2 to what power is 16? So the answer is 4, because 2 to the 4th power is 16. For one like this, I say 4 to what power is 16? So 4 to the what is 16? So the answer I'm looking for is 2. And on this last one, I'm saying 3 to what power is 1? 3 to something has to equal 1, or 3 to the x has to equal 1. So my answer has to be 0, because anything to the 0 power is 1. Go ahead and pause your video, try some of the rest of these, and then we'll go through them quickly. Okay, as we look at the rest of these, that's going to be a 1, because 9 to the 1 is 9. This has an understood base of 10, remember, so 10 to the 4th power is 10,000. 3 to the -1 is 1/3. 16 to the 1/2, aka square root of 16, is 4. 2 to the -1 is 1/2. This is an understood 10 again, so 10 squared is 100. This has a base of 5, so 5 to the 1st power is 5. This one is basically saying 7 to what power is 7 to the 5th. No need to multiply that out, 7 to the 5th. 7 to the 5th is equal to 7 to the 5th, so the missing exponent is a 5. And on this last one, remember this is a base e, so it's basically saying e to what power is equal to e. Well, in this case, e to the 1 is the same thing as e, so your answer for ln of e is just a 1. Okay. Now, if you get stuck on these, you can always remember evaluate them in Desmos. So for one with a base like that, log 2 of 16, I can go over to Desmos, and I can just pull up my functions menu, and then remember to pick the one with that. So log base 2 of 16 will give you a 4. Now, if you ever have one that may have a fraction in it as a base, just put a variable in there. And now, for example, and then when it says sliders are always good. They're very tasty. So now I can let it equal whatever my fraction is, and it'll evaluate for that fractional base. But that's the only way Desmos will do a fractional base for you.